All right, let's talk about it. It's one of the biggest, most crucial decisions you're going to make on AWS. How do you pick the right database when you know you need to handle massive scale? We're always told there are these two simple paths for scaling your database. But is that really the whole story? It turns out the way we've been taught to think about this, well, it might actually be what's holding us back.
So path number one, the one everyone talks about, is scaling out. Super simple concept, right? Need more horsepower? Just throw more machines at the problem. Add another server, then another, and another.
And path number two is scaling up. This is the opposite approach. Instead of more machines, you just make the one you have a beast. You beef it up with more CPU, more RAM. You're basically swapping out the engine for a bigger one.
Okay, and this is the whole point. Thinking this is a simple either-or choice, that's a trap. It's a huge trap, and it's one that leads directly to bad performance, a ton of instability, and a bill from AWS that'll make your eyes water. So in this explainer, we're going to tear that trap apart. We're going to introduce a completely new way to think about this, a new mental model, and we'll use it to look at two of the heavyweights on AWS, DynamoDB and RDS.
All right, first up, let's dig into why sticking to just one of these paths is almost always the wrong move.
So think about it. If you only scale out, you're just adding more and more servers. That sounds great, but it gets messy. All those machines have to constantly talk to each other, and that's what we call coordination overhead. It gets really expensive, and the system is always busy shuffling data around, which is super disruptive. But if you only scale up, well, you eventually hit a brick wall, a literal hardware ceiling, and the returns just get worse and worse. It's like pouring money into a 10-year-old laptop. At some point, it just can't get any faster. Okay, so if that old map is broken, what's the replacement? Well, luckily for us, some recent research has given us a really powerful new way to visualize the whole problem. It's called the scaling plane. Forget two separate paths. I want you to picture a two-dimensional map. The horizontal axis, that's your scale out, the number of servers you have. The vertical axis, that's scale up, how powerful each one of those servers is. So any database setup you can imagine, it's just a single dot somewhere on this plane. And here is the absolute game changer from that research. The best path, the cheapest, the fastest, the most stable, it isn't just straight across or straight up. Nope, it's cutting a diagonal path right through the middle of this map. And this idea of moving diagonally, tweaking both the number of servers and their power at the same time, this isn't just some academic theory. The benefits are real, they are measurable, and frankly, they're pretty dramatic. Okay, benefit number one, stability. Just look at this chart. See that bar on the left for diagonal scale? It has way fewer of these rebalance events. And trust me, you hate rebalancing. It's when your database is just shuffling data around instead of doing real work. The diagonal path just gives you a much, much smoother ride compared to only scaling horizontally. Next up, performance. This graph is awesome. It shows latency as the workload changes. And look at that gold line at the bottom. That's our diagonal path. It is just low and stable. No crazy spikes, no unpredictability, just rock-solid, fast performance. And finally, the big one. The one we all really care about, right? Cost. Once again, look at that gold line. It's just cheaper, period. Because you're being smart about it, adding a little power here, a new server there, you stop wasting money on resources you don't actually need. You avoid that classic over-provisioning problem. Okay, so now that we have this new map, this scaling plane, let's use it to understand the big AWS databases. First up, the titan of NoSQL, Amazon DynamoDB. If you read the AWS docs, they talk about DynamoDB's seamless scalability. And the key phrase, the one to really pay attention to, is that it automatically spreads data and traffic over servers. What does that sound like? Yep, that is pure scale out. And that just perfectly places it on our map, doesn't it? DynamoDB is the undisputed champion of the horizontal path. You just tell it how many reads and writes you need, and poof, AWS handles all the magic behind the curtain. Adding and removing servers, DynamoDB lives and breathes on that horizontal H-axis. All right, so what about the other side of the coin, the relational king, Amazon RDS? Well, its strategy is totally different. It follows a much more hybrid path on our scaling plane. With RDS, your first move is almost always vertical. You pick an instance size, you scale up from a T3 micro to an M5 large, and so on. But that's not the only trick it has. If your app is getting hammered with read requests, you can then start to scale out by adding what are called read replicas.
So you see, RDS takes a totally different route on our map. You start by climbing straight up that vertical v-axis, making your main server a powerhouse. Then, once you need to, you start moving sideways, horizontally, by adding those replicas.
And this brings us to the most important point of all. There's no such thing as the best database. It's a myth. The real key is to understand the shape of your workload so you can pick the right starting strategy on the scaling plane. This table pretty much says it all. Got a workload that's huge, spiky, unpredictable with tons of writes? That's what DynamoDB's horizontal path was born for. On the other hand, if your growth is more predictable, or if you're mostly just reading data, then the RDS path, scaling up first, then out, is probably going to be a much better fit. So let me leave you with this final thought. The science is pretty clear here. The best path, the truly optimal one, is almost always that diagonal one. So the future of databases, it's not about us having to choose between horizontal or vertical. It's about databases that are smart enough to figure out that perfect diagonal path all by themselves, in real time. So the big question you have to ask is my application's architecture ready for that future?